You look up at the night sky, but instead of seeing the familiar white glow of the moon, you see Jupiter. The gas giant fills the entire sky from horizon to horizon, its swirling clouds and great red spot dominating everything. The tides are going insane, tsunamis hundreds of meters tall. The ground is shaking from constant earthquakes, and you realize with horror, Earth is being ripped apart. What would really happen if another planet replaced our moon? Let's find out. Imagine the scenario. An alien world. Imagine if one day you looked up into the night sky and saw Mars or Saturn where the moon was supposed to be. That sight alone would turn our Earth into an alien world. Something out of science fiction made real. And it wouldn't just be because of the new view. As spectacular as that would be, the consequences would go far beyond aesthetics. How would replacing the moon change Earth's orbit and rotation? What would happen to our tides, our climate, our very survival? What planet could we safely replace our moon with, if any? Which replacement would be merely inconvenient, and which would be absolutely catastrophic? And what planet would be the most disastrous of all, spelling doom for life on Earth? These aren't just fun thought experiments. By exploring what would happen if each planet replaced our moon, we can better understand the delicate balance that makes Earth habitable and appreciate the crucial role our moon plays in keeping us alive. Before we start swapping planets around, we need to understand just how important the moon is to Earth. We often take the moon for granted. It's just always been there, lighting up the night sky, going through its phases. But the moon does so much more than provide a pretty view. We can thank the moon for predictable weather patterns. The moon's gravitational influence helps regulate atmospheric circulation, contributing to stable climate patterns that life has adapted to over millions of years. We can thank the moon for ocean currents and the circulation of important nutrients. The moon creates tides that drive ocean currents, mixing nutrients from the deep ocean up to the surface where marine life can access them. Without these tidal currents, ocean ecosystems would be fundamentally different and likely less productive. Most critically, the moon helps stabilize Earth's axial tilt. Earth is tilted at approximately 23.5 degrees relative to its orbital plane. This tilt is what gives us seasons. But without the moon's gravitational influence, this tilt would vary wildly over time. Take away the moon, and Earth would go wobbling all over the place. The axial tilt could swing from nearly 0 degrees to as much as 85 degrees over millions of years. This would cause what I can only describe as climate change on steroids, far more extreme than anything we're currently experiencing. Sometimes Earth's poles would point almost directly at the sun, creating extreme seasonal variations. Other times the poles would barely tilt at all, virtually eliminating seasons. This instability would make long-term climate prediction impossible and would have prevented complex life from evolving in the first place. So the moon isn't just a pretty nightlight, it's essential to Earth's habitability. But for this thought experiment, we wouldn't just let the moon take a day off and leave Earth to wobble uncontrollably. We would find it a replacement from another part of our solar system. For this scenario, we're going to place each planet at the same distance from Earth that the moon currently orbits, approximately 384,400 kilometers away. This is about 30 times Earth's diameter, or roughly the distance light travels in 1.25 seconds. At this distance, we'll see how each planet would appear in our sky and what gravitational effects it would have on Earth. Some planets would look spectacular, others would look terrifying, and some would immediately destroy Earth. The moon has a diameter of about 3,475 kilometers. It has a mass of about 73 quintillion kilograms. Its gravity is strong enough to raise tides on Earth, but not so strong as to destabilize our planet. So what would happen if we swapped our moon with planets that range from slightly smaller to 41 times larger? Let's go through each one, starting with the smallest and working our way up to the absolute monsters. Let's start with Pluto. Yes, I know Pluto is technically a dwarf planet, not a full planet, but we're including it anyway because it's interesting. Pluto wouldn't look much different than our current moon in the night sky. In fact, it would look smaller because Pluto has a diameter of only about 2,370 kilometers, about 2/3 the diameter of our moon, and this smaller size wouldn't be good for Earth. That's because Pluto's gravitational pull would be much weaker than that of the Moon. Pluto has only about 1/6 the mass of the Moon, so its gravitational influence on Earth would be dramatically reduced. With such weak gravitational stabilization, Earth would begin wobbling all over the place. Our axial tilt would become unstable, varying wildly over geological timescales. This would result in dramatic climate change far worse than what losing the Moon entirely would cause. Well, actually, it would be similar to losing the Moon. Since Pluto is so small, it might as well not be there. The Moon's gravitational pull is responsible for our daily ocean tides. Because Pluto is so much smaller and lighter than our Moon, our ocean tides would become much weaker, only about 1/6 their current strength. This would devastate important marine ecosystems that depend on tidal zones. Many species have evolved to live in areas that are alternately covered and exposed by tides. Reduce the tides too much, and these species lose their habitats. The mixing of nutrients would also decrease, harming ocean productivity. So Pluto would be a terrible replacement for our Moon. All the disadvantages of losing the Moon, with the only benefit being a slightly different view in the night sky. Now let's move on to an actual planet, Mercury, the smallest planet in our solar system. Mercury would look quite a lot like our current Moon. It has a dark gray surface covered in asteroid craters, giving it a similar appearance. You probably wouldn't be able to tell them apart at first glance from Earth. Mercury is only about 1.4 times the diameter of the Moon, so it wouldn't look dramatically larger in the sky. It would be noticeably bigger, about 40% larger in apparent size, but not shockingly so. Because Mercury's mass is only about 4.5 times that of the Moon, its gravitational effects on Earth would be stronger, but not catastrophically so. Tides would be more powerful, roughly 4 to 5 times stronger than current tides. This would be significant but manageable. Coastal areas would need to adapt to the higher tides, but it wouldn't be an extinction-level problem. Earth's rotation would slow down slightly due to Mercury's stronger tidal forces, making days somewhat longer. But again, this would happen gradually over millions of years, giving life plenty of time to adapt. Out of all the planets in our solar system, Mercury would be the safest one to replace our Moon with. It's similar enough in size and mass that it wouldn't cause catastrophic disruptions, while being different enough to create some interesting changes. If we had to choose a replacement, Mercury would be the least bad option. Having the red planet in our night sky would be quite a sight to behold. Mars would dominate the night sky much more than our current Moon does. Mars has a diameter of about 6,790 kilometers, nearly twice the diameter of the Moon. In our sky, it would appear about twice as large, which is very noticeable. Instead of the Moon taking up about half a degree of sky, Mars would take up about 1 degree. All the iron oxide on Mars's surface would make it glow an eerie, distinctive red color. No more white moonlight shining through your window at night. Instead, everything outdoors at night would be bathed in an eerie reddish glow. The moonlight would be red light, giving nighttime landscapes an alien, otherworldly appearance. Mars's mass is about 11% of Earth's mass, or about 9 times the Moon's mass. This means Mars would have a much stronger gravitational pull on Earth than the Moon does. Mars's stronger gravitational pull would have complex effects on ocean tides. Paradoxically, tsunamis caused by earthquakes might actually be smaller because the stronger background gravitational field would dampen some wave dynamics. But normal everyday waves and tides would be much more massive and powerful. The stronger tidal forces would also cause Earth's rotation to slow down more rapidly. Over time, thousands to millions of years, Earth's days would become noticeably longer. We might end up with 25 or 30-hour days instead of 24 hours. Hopefully, we'd still keep a 40-hour work week measured in hours, because a 16-hour workday doesn't sound appealing at all. Though knowing how things usually go, we'd probably end up working longer actual time periods. Mars would be spectacular to look at, but would cause significant long-term changes to Earth's rotation and tides. With Venus in our night sky, we might never experience true darkness again. Venus is already the brightest natural object in our night sky after the Moon, but that's when it's tens of millions of kilometers away. Place it at the Moon's distance, and the effect would be dramatic. Venus is the brightest planet in our solar system due to its highly reflective clouds. It has an albedo of about 0.75, meaning it reflects 75% of the sunlight that hits it. The moon, by comparison, reflects only about 12% of sunlight. Venus would reflect about 60% more light than the moon currently does, despite their similar sizes. And Venus is larger than the moon, about 3.5 times the diameter, making it about 12 times larger in area. So not only would it be brighter per unit area, it would be much larger in the sky. The night sky would never truly be dark. It would be more like perpetual twilight. You probably couldn't see stars except during the new Venus phase, when it was between Earth and the Sun. Astronomers would be very unhappy. But there's a much bigger problem than light pollution. Because Venus is so massive, about 67% of Earth's mass, or about 600 times the moon's mass, it would force Earth into a binary system. Earth and Venus would orbit around a common center of mass between them, rather than Venus simply orbiting Earth. This would be beautiful to watch. The phases of Venus would be spectacular as this massive planet went from crescent to full and back again. But it would also be absolutely disastrous. Simulations of binary planetary systems like this usually end with the planets either colliding with each other or merging together over millions of years due to tidal interactions. Or one planet might be ejected from the system entirely. So Venus would give us a spectacular view for a while, but ultimately it would doom Earth. Uranus and Neptune are both ice giants and are similar enough in size that we can discuss them together. Both would be absolutely enormous in our sky. A huge portion of our sky would be taken up by these massive worlds. Uranus is about 4 times the diameter of Earth, while Neptune is slightly smaller at about 3.9 times Earth's diameter. Both are roughly 14 to 15 times the diameter of the Moon. In our sky, they would appear 14 to 15 times larger than the Moon, taking up about 7 to 8 degrees of sky. That's about 15 times the apparent size of the Moon. They would be absolutely massive, dominating the entire visible sky. Uranus would have a pale blue-green color due to methane in its atmosphere, but Uranus has another memorable characteristic. It would stink horribly. Uranus's upper atmosphere contains hydrogen sulfide, the chemical that gives rotten eggs their smell. Of course, this smell wouldn't reach Earth's surface, but it's an amusing fact. No wonder this fart-smelling planet got such an unfortunate name. Neptune would be a deeper, richer blue color, one of the most beautiful sights imaginable. Its deep azure color would be stunning in our sky. But beauty aside, both planets would cause catastrophic problems. Since both Uranus and Neptune are about 14 to 15 times the size of the Moon and about 17 times the mass of Earth, their impact on Earth's rotation and tidal systems would be absolutely drastic. The tides would be apocalyptic. We're talking waves potentially hundreds of meters high. Most coastal areas would be completely uninhabitable. Beach houses would have to be built on cliffs kilometers inland and hundreds of meters high, far away from the reach of the enormous waves. Earth's rotation would be severely affected. We might end up tidally locked to these planets, with one side of Earth perpetually facing the ice giant. One hemisphere would always see the massive planet in the sky, while the other would never see it. Both planets would also probably pull Earth into a binary system, with all the associated long-term stability problems. Seeing Saturn up in the night sky has to be among the most spectacular sights we could imagine. Its pale yellow color and magnificent ring system would be absolutely stunning, a view that would make every night magical. Saturn is about 9 times the diameter of Earth and about 95 times the mass of Earth. It's enormous, about 26 times the diameter of the Moon. In our sky, Saturn would take up about 13 degrees, about 26 times the Moon's apparent size. It would stretch across a significant portion of the sky, and those rings would be visible in incredible detail. The rings would appear as bright bands extending far on either side of the planet. Depending on the orientation, they might look like bright lines cutting across the planet, or we might see them edge on as a thin, bright line through the middle of Saturn. But there would be some serious complications with having Saturn as our moon. Because Saturn is so large and massive, Earth would quickly become Saturn's moon rather than the other way around. We'd be captured by Saturn's gravity and end up orbiting it. And if Earth orbited around Saturn instead of the Sun, it simply wouldn't be the Earth as we know it today. We'd be too far from the sun to receive adequate warmth. Earth would freeze over completely. The only possible heat source would be tidal heating from orbiting Saturn, but even that probably wouldn't be enough to keep Earth habitable. So while Saturn would be the most beautiful replacement for our moon, it would also transform Earth so fundamentally that it would no longer be the world we know. Finally, let's move on to the absolute monster, Jupiter, the largest planet in our solar system. At 41 times the diameter of the moon, Jupiter would be absolutely incomprehensible in our sky. You wouldn't even be able to see the north and south poles of the gas giant. Jupiter would fill the entire sky from horizon to horizon in the direction it was located. The Great Red Spot, a storm larger than Earth itself, would be clearly visible, slowly rotating across the face of the planet. The cloud bands would be visible in exquisite detail. It would be the most awe-inspiring, terrifying sight any human had ever witnessed. But this beautiful view would last only a short time before Jupiter destroyed Earth completely. Similar to the situation with Saturn, Earth would quickly become Jupiter's moon rather than Jupiter being Earth's moon. We'd be captured by Jupiter's enormous gravity and pulled into orbit around the gas giant. Only the situation with Jupiter would be far worse than with Saturn. Because Jupiter is so incredibly massive, 318 times the mass of Earth, the gravitational effects would be catastrophic and immediate. The side of Earth closest to Jupiter would experience a much stronger gravitational pull than the opposite side of Earth. This difference in gravitational force across Earth's diameter is called a tidal force, and with Jupiter it would be enormous. This tidal force would literally distort the shape of Earth. Our planet would be stretched into an egg shape with the long axis pointing toward Jupiter. The crust would crack and heave. The interior would be churned and heated by the constant flexing. All this pulling and stretching would create frequent and violent volcanic eruptions across the entire planet. Earthquakes would be constant and devastating. The ground would never stop shaking, and ultimately Jupiter's gravitational pull would simply tear Earth apart. Within a relatively short time, possibly just days or weeks, Earth would be ripped into pieces by Jupiter's gravity. Those pieces would form a ring of rocky debris around Jupiter, joining its existing faint ring system. Earth would become just another ring around the solar system's largest planet. So if you found yourself looking up to see Jupiter in place of the moon, you should enjoy the view while it lasts, because it won't last long. You'd have perhaps a few hours to admire the most spectacular sight in the solar system before the earthquakes and volcanic eruptions made life impossible, and then Earth itself would cease to exist. Mercury would be safest. Mars would be beautiful but problematic. Venus would doom us in a binary system. Saturn would freeze us. Jupiter would destroy Earth within days. The views would be spectacular. Alien skies with massive planets. But almost every replacement would spell doom. So appreciate that boring gray moon. It's kept Earth stable for billions of years. We're lucky to have it. If you enjoyed this planetary tour, subscribe for more explorations of what makes our world habitable. Stay curious.